Good afternoon, everyone. Today we're going to look at simplifying an expression with a bunch of different radicals. Okay? So for the first one, we have inside the radical, we have a number and we have a variable x to the power of 3. And so we're going to seek to simplify both of those parts. So we'll leave the 4 outside, and then we're dealing with the square root. And so to simplify the square root of 45, we're looking for a factor of 45 that is itself a perfect square, knowing that when we take the square root of a perfect square, we get a nice integer out of it. And so what I'm going to do is rewrite 45 as 9 times 5, knowing that 9 is a perfect square, okay? And then you know that the square root of x is the same thing as x to the power of 1/2. And so taking the square root of something is the same as raising it to the power of 1/2. That's why, for example, if we take the square root of x to the 4, what we're really doing is raising x to the 4 to the power of 1/2. And there is one of our basic exponent laws that says when we have a power to a power, we multiply the powers. And so, for example, the square root of 4 is akin to raising x to the power of 4 times 1/2, which is just x squared, or in a quicker way, the square root of x to the 4 is x squared. We're just having that exponent when we take the square root. When we take the cube root, we're dividing the exponent by 3, because we would be raising whatever is inside the radical to the power of 1/3, and so on and so forth for all of the different roots. So for us, we're always dealing with square roots, and so we're always going to divide the exponent by 2 by taking the square root of it. And so what that means for us is we're going to write x cubed as x squared times x. Okay? So now we have 9 times 5 times x squared times x, which is just 45x cubed, just written in another way. And we're going to do the same thing for all of the others. Now 27 has a factor that is a perfect square in 9. 27 is 9 times 3. And then there's nothing we can do with the x, so we'll just leave it as it is. Okay? Next, 17. There's nothing we can do with root 3x, right? Neither 3 nor x can be simplified any further through a square root, and so we just leave it as it is. And finally, 9 times 125. What's the biggest factor of 125 that is a perfect square? That'll be, if you think about it, 25, and 25 times 5 will get us back 125. And then again, x cubed, just like we did at the start, can be written as x squared times x, right? And now we are ready to simplify. So what we're going to do is we'll have 4 times. Now I'm going to do this a little bit, how would you say? I'm going to do this a little bit unsophisticatedly, let's say, but hopefully you'll get the idea. And so we have the square root of all of these things multiplied through, and so that means we can take the square root of each one individually. Okay, I'm not going to write it all out because it'll take a lot of space, but we have the square root of 9, and we know that first and foremost that's 3. And next we have the square root of 5. That can't be simplified, so we'll leave that as it is. The square root of x squared is just x, and so we get an x, and again the square root of x, that can't be simplified, so we'll leave it as it is. And so the 9 kind of got taken care of, and the x squared kind of got taken care of in taking their square roots and getting something simpler out of it, but the 5 and the x didn't. And so we'll leave that underneath the square root, like so, okay? Now, for the next part, we'll do the same thing with the 9. The square root of 9 is 3, so we'll have 3, but the 3x that's under the square root, that can't be simplified any further, and so we'll leave that as root 3x. Next we'll have plus 17. Root 3x, there's nothing going on there. And finally, we have 9 times the square root of 25, right? That's why we wanted a perfect square. That was a factor of 125. The square root of 25 is 5, so we'll have 9 times 5. Next, x squared can also be evaluated for its square root. The square root of x squared is x. And then the 5 and the x can't be simplified any further through square root, and so they'll stay under that square root. Let me write that as in green to be consistent. And so this is our next line, and now we can multiply through everything in front of the radicals. And so we'll have in this one 12x times root 5x minus 3 root 3x plus 17 root 3x minus 45x root 5x. And now we can simplify this a little bit more by grouping like terms, like radicals, and that means specifically radicals with the exact same radicand, meaning the exact same thing underneath the root symbol. And so you'll see rather quickly that you have 5x's and 5x's and 3x's and 3x's. You can combine those, right? These two will go together, and I'll use a different color. The 5x under the square roots will go together. And so in the end, you'll end up with 12x root 5x minus 45x root 5x. Together, that'll be negative 37 root 5x. And for the root 3x's, we'll have negative 3 plus 17, and so that'll be plus 14 root 3x. And usually we like having the positive term first, and so to be proper, I'll write this as 14 root 3x minus 37 root 5x. And this is what I would do for my final answer. So I hope that helps. I hope you're starting to see how we simplify through radicals to get the simplest expression possible in the end. And if you guys have any other questions like this that you'd like to see a video of, please do let me know. Comment below, and thanks for watching.